Broadcast domain. Let's first of all go and see the definition, what it is, then we'll try to understand this. So what here it says is the broadcast domain is logical division of computer network. Means simply say network, logical division of network in which all nodes here means computer or any device that can participate in networking, means even router. It can be a router, it can be a printer, it can be laptop, PC. So that's what node means. The devices in the network, we call it as node. So in which all nodes can reach each other by broadcast at layer 2. That's why it is called as data link layer 2. So layer 2 means MAC address. The broadcast domain can be within the same LAN segment or it can be bridged to the other LAN. Forget about this right now. Let us focus on this one first. A broadcast domain is a logical division of computer network in which all nodes can reach each other by broadcast at layer 2. So when I have some devices connected, now this is a broadcast domain. This one is another broadcast domain. Why? If this computer, if it sends a layer 2 broadcast packet, layer 2 broadcast means data link layer, here it is written here, see. Data link layer means layer 2, meaning MAC address. If this computer send a layer 2 broadcast, meaning the destination MAC address is a layer 2 broadcast address. The destination address of the packet that it generates is a layer 2 broadcast address. What is broadcast address? The address that can take the packet to everyone. That is what called as broadcast address. See, if I write a letter to you, it's not broadcast, it's unicast. When I write a letter to anyone on earth, which is a broadcast packet, because its destination is anyone. Whoever receives that letter, they can own it, because the destination address is a broadcast address. So When a computer or a node, means it can be any device that communicates. That's what node. So when a node sends a layer 2 broadcast packet, if that layer 2 broadcast packet can be reached, then they are all in one single broadcast domain. When a layer 2 broadcast packet is sent, if these PCs, this port of the router, if these devices can receive the packet, which means they are all in single broadcast domain. When they are in different broadcast domain, they cannot receive it. When a layer 2 broadcast packet is sent, if these are all receiving it, which means they are in a single group, single layer 2 group. Single layer 2 group is what called as technically broadcast domain. They're all in one group. Domain means what? Control. Broadcast control. When the broadcast packet is sent, it is received by this, but it is not sent like this. It cannot go like this. Why? Because the router is a layer 3 device. It won't allow layer 2 to penetrate. It won't allow layer 2 broadcast to pass through. Because there is a broadcast controller there. There is a broadcast domain there. When a broadcast packet comes, it will come only up to here. It won't allow to pass through. Because every port has got one controller on router. Whereas in a switch which is called as layer 2 device, all the ports of the switch are in single broadcast domain, single group. Whereas on router, every port is in different broadcast domain. So when a packet comes to a broadcast domain, it won't allow to pass to another broadcast domain because it's another. So what is a broadcast domain? It's a logical division of network. In another word, it's a layer 2 group of device in a network. So what this group of device can do? They can reach each other in a layer 2 level. If someone wants to reach all networks, if someone wants to reach this network, then it needs to be a layer 3 broadcast, layer 3 broadcast. This is layer 2 broadcast. This is what we call as broadcast domain. This is one group, this is another group. The packet that is sent as layer 2 broadcast from here will impact only the devices that are within this brown rectangle, which means they are in one broadcast domain. Likewise, the layer 2 broadcast, the MAC address based broadcast, remember yesterday we learned about the size of MAC address, which is a layer 2 48 bit address. When a packet is sent as a layer 2 broadcast using a layer 2 broadcast address, if that packet can reach this, and this point, which means they are all in single group, single broadcast domain. So in this picture, we have two broadcast domains, the brown and the blue. They are separate broadcast domains. So each broadcast domain is a LAN segment. Each broadcast domain is one LAN segment. Do not worry about this point. Somewhere it can be bridged to another LAN. Means don't worry about that. It's talking about a tunnel, layer 2 tunnel. If you put this tunnel and send the traffic through this, then the router is hidden. If the router is hidden because you're going through the tunnel, then these two will form one big broadcast domain. That's not needed now. What is a broadcast domain? It's a logical division of computer network. And those devices in that network should reach each other when a broadcast packet is sent. Should receive the packet when a layer 2 broadcast packet is sent. So example, a switch connected through some devices. They all will be receiving their layer 2 broadcast packet. But when we have devices in different LAN, which is connected through a router, each LAN is a broadcast domain. So I have two broadcast domains. The broadcast packet that is coming from here will not be allowed to pass through. Because every port has got a broadcast controller. It will stop the broadcast there. Routers will not take the broadcast traffic of one broadcast domain and give it to other broadcast domain. It won't allow the broadcast traffic to go like that. Now for each broadcast domain, we will have different networks. Say for example, this is 10.0.0.1 network. It's 10.0.0.2 network, 10.0.0.3. And here is another network, 20.0.0.1. And in this port of the router, this is how we draw a router. This is connected to 20.0.0, let's say 10. Here 10.0.0.10. You see, these are all 10 network. This is all 20 network. This is one LAN, LAN 2. This is another LAN, LAN 1. So you got two broadcast domain, LAN 1 and LAN 2. LAN 1 belongs to 10 network, LAN 2 belongs to 20 network. To connect between two different network, what you need is a router. Without the help of a router, you will not be able to communicate from one network to another network. 10 and 20, they are two different networks. Within the same network, you need just a switch. You don't need a router. Switch we draw as a rectangle. You see, all are in same network 20, 20, 20, beginning with 20, number 20. Here, every IP address starts with 10. So, when we say one broadcast domain, what does it mean? It means one local area network, LAN. What is one LAN? The members of same network forms one LAN, one local area network. Members of same network. Here I have two networks, two LANs. Intercommunication between the LAN is only possible with the help of router. Do we need a router to communicate between the devices in same broadcast domain? I repeat the question. Do we need a router to communicate between the devices that are in single broadcast domain? No, I repeat the question. No, wait. My question is, do we need a router? See, router is this one. Like, yeah. Do we need a router to make the communication to happen between the devices that are in single broadcast domain? Hmm? No. Only between different broadcast domain we need a router. Only between different broadcast domain. In another word, only between two different LAN. In another word, between two different network. Yeah. Okay. Now let us learn collusion domain. Now, collusion domain, what is it? See the word collusion. Collusion means they dash each other as they communicate. The data which is sent in the form of frames, packets. I can call it as packet also. It's okay now. The data that is going. See, if I have a switch, we call it as a LAN device, and you got some computers. 10.0.0.1, let's say 10.0.0.2. Now, if it is hub, if this central box is a hub, will it learn MAC address? No, hub never learned MAC address. So hub will not know who is connected where. Let's take the MAC address of these devices E, PPP, CCC, and DDD. Hub never maintains any MAC table, never learned MAC address. We learned this in the previous class. Because of this reason, whenever this is talking to DDDD, it not only goes to DDDD, it goes to everyone. Because it does not know. Hub do not know where is DDDD. Likewise, when DDDD communicates to A, it is not only going to A, it also goes to C and B. Likewise, when B talks, it goes to everyone. When C talks, see now drawing itself is making picture like a big chaos. Now, this is what called as collusion. If everyone tries to talk, then there is a collusion. They hit each other. There's a collusion here. Because for all the devices, there is only one collision domain. In hub, there is only one collision domain. Whereas the switches, learn MAC address. Port 3. Switches learn MAC address. As the packet comes, the source MAC address is learned. So it learns like this. In P0, someone called BBB is connected. In P1, someone called AAA is connected. In P2, DDD is connected. In P3, CCC is connected. We learned this in the previous class. Now, whenever this is sending a packet to DDD, this time it goes only to port 2, because port 2 is where DDD is connected. See, you avoid collusion, you see here. Now, when P1 is talking to P2, P3 can talk to P0. No one is going to collide. They're not going to collide. Because every port learns MAC address, they got their own path. Collision control. That is what called as collision domain. Collision control. Now read the statement, you'll understand. Collision domain is a network segment connected by a shared media. Of course, this is a shared switch for everyone, shared media. But if it is a repeater or hub, there will be a collision. Because for the entire box, there is one collision domain, one shared media. Whereas here, every port learns the MAC address. So each port has got a collision domain. Remember, I told you, if you have 48 port switch, you will have 48 collision domain. Collision controller. Right, so we have learned what is collision domain and what is broadcast domain. Now, let's learn something with respect to collision domain and broadcast domain. Assume I have a 8-port hub to which some devices are connected. It's an 8-port hub. Hub never learned MAC address. Hub has got one collision domain only for the whole device and one broadcast domain. Only one. And now we understand what is broadcast domain, meaning they're all in one group. All these devices that are connected are in one group. Not only that, when all four communicates, hub cannot tolerate, because there is no learning of MAC address. If all tries to talk at the same time, definitely there is a collision, because they're all in one group. And hub do not know who is connected where. But when I take a switch with 8 ports, assume I have 8-port switch. How many collision domain? 8 collision domain, because each port can learn MAC address and they can forward the packet right to the port where destination is connected, because they know the location of the connected device. That avoids collusion. And in a switch, how many broadcast domain? Only one. Right. What about the router? Let's say I have a router with 4 ports. Router, this is how we draw. Each port has got a collision domain and broadcast domain. So there will be 4 broadcast domain and 4 collision domain. See, each port belong to different network. So router know which port belong to what network. So that solves the collision problem. Because the router knows what network on which port. Like switch knows what MAC address is on what port. Router also knows what network, what IP address, what network address on what port. For example, in this link you'll have 10 network connected. In this link 20 network connected. In this link 30 network. So router knows who is connected where, which network is connected to which port. So each port has got a collision domain. Not only that, I told you when a broadcast packet comes, it will never allow to flag, which means they're all not in same group. They're in 4 different groups. Right? So this understanding is very important. In order to understand this, we learned this. For almost half an hour, we learned this. Just to understand this. Do you have a question? I'm going to ask you a question now, and you please try to answer. If I have a switch of 42 port, it's a switch. It's a layer 2 device switch. How many collision domain and how many broadcast domain I'll have? Correct. One broadcast domain. Very well said. Now, when I take that 42 port switch and connect to a router, and that router is connected to another hub, how many collision domain and how many broadcast domain I have in total? Yep. No. Yeah, this is 42 port, and this is an 8-port hub. Now, what is the total number of collision domain and broadcast domain in this topology? And the whole thing? Yeah, all. Would I do them separate or just add it all up? I'm sorry. Give it a try. So for the router, I thought we had to have ports. So this is 42 ports. You said the hub only can have 8 ports. See, this hub has got 8 port. The router has got 2 ports here, and switch has got 42. What will be the total number of collision domain and broadcast domain is what question? Okay, let me help you with this. Okay, so we know the hub has got one collision domain and one broadcast domain. So because you're connecting hub up to here, so up to here is what one collision domain and one broadcast domain. Because router on this port it has got a separate collision domain and broadcast domain. We just saw each port on the router has got a collision domain and broadcast domain. So when you connect this port and this port, the collision domain of the hub is extended up to here. The broadcast domain of the hub is extended up to here. So this is in this side it is only 1 and 1. Whereas here again 1 broadcast domain but 42 collision domain. So totally 43 collision domain and 2 broadcast domain.
Okay, I think I was just overthinking that. Just trying to separate it. I know the port, for the hub, it only can be one controller, one domain, and one.
Okay, I'll ask you another one. This time you try. I have a hub and I have another hub and I got a router connected, and this is 4-port hub and this is 8-port hub. Now what is the total number of collision domain and broadcast domain? No, you remember we learned whatever the number of port may be, the collision domain and broadcast domain is only one. Yeah, correct. 2 and 2. Yeah. So this is 2. This is one collision domain, and this is another collision domain, and this is one broadcast domain, another broadcast domain. Wonderful. You understood this topic very well. So today we had a topic called broadcast domain and collision domain, and we saw that broadcast domain is a logical division of network in which all the networks, all the nodes can reach each other by broadcast at the layer 2, at the data link layer, at the MAC address level. Then collision domain is a network segment connected by shared medium like a repeater. When a packet is sent, every device simultaneously receives the packet. If all devices start communicating at the same time, there are chances of collision. So collision domain is the one which controls the collision. In the repeater, there is no control of collision, only one collision domain for the whole device. Whereas in the switch, every port learns the MAC address. So there is no chance of collision because every connected device is learned in a table called MACTIB. Then
for the switch, every port has a collision domain.
Come again?
For the switch, every port.
Yeah, exactly. For a switch, every port has got a collision controller, collision domain. And router, every port has got their own collision domain and broadcast domain. If I have 4-port router, then there is 4 broadcast domain and 4 collision domain. To check whether we understood that, we did an exercise. You did very well. Fine.